أهلا وسهلا، حياك الله.
أهلا، حياك الله.
كيف حالك؟ إن شاء الله بخير.
الحمد لله، الأمور تمام. أخباركم؟ إن شاء الله العروض ماشية تمام.
الحمد لله الحمد لله، كل الأمور تمام إن شاء الله، وبالعكس والله متحمسين لمشاركتك الأخيرة معنا اللي حتكون أنا
وأنا متحمس
مسك الختام لليالي تقنية. يعني إحنا ما شاء الله كنا على مدار يعني 7 ليالي، ومحظوظين إنه هذه الليلة ما شاء الله مدخمة بالمشاركات 3 وآخرها يعني وجودك. فالحمد لله إنه يعني كانت في هذه الفرصة إنه والله تكونوا موجودين معنا كشركة مزن مشاركين معرفين، وكذلك وجودك أنت معنا شخصيا. أنا صراحة الله يعافيك ويسلمك، أنا يعني ما أتوقع عندي يعني إضافات كثير، لكن إذا تسمح لي في عادة يعني سؤال نسأله في سلايدو عن مدى تقريبا خلينا نقول توقع الناس للمشاركة اللي حتقدمها بإذن الله. فإن شاء الله نتوقع سقف التوقعات غالبا حيكون عالي، يعني كونك ما شاء الله تبارك الله من شركة مزن. شركة مزن معروفة من أكثر الشركات التقنية المميزة على مستوى السعودية، وما شاء الله من أيضا من الشركات اللي موجودة في برنامج الشركات المليارية. فأكيد يعني متوقعين الطاقم الانجينيرز اللي في مزن يعني أكيد حتكون إن شاء الله مشاركة جدا مميزة. فشايف يعني 9.4 من أصل 10، فهذا إن كان يدل على شيء يدل على يعني إن شاء الله بإذن الله يعني تكون مشاركة جدا مميزة. الله يعطيك العافية. طيب
أنا توصل توقعات وتتحدى
إن شاء الله بإذن الله. طيب أنا خليني بس أقفل الشاشات الزيادة ويصير تقدر تتفضل. يعطيك العافية بالمشاركة، مع كل أمنياتي لك بالتوفيق. تفضل، الله يعافيك.
شكرا. صفحة. السلام عليكم، أنا معكم يوسف الدليجان. العرض بس كعنوان كتعريفي اللي هو A Tale of Simplification, How Simplifying an Implementation and Profiling Can Lead to a Better System. فالفكرة عن كملخص بدائي البرزنتيشن هذا راح يكون عن internal system بمزن طورناه في البداية to support ولا to provide a feature for customers. بس مع الوقت اتضحت لنا فيها مشاكل كثيرة، ومع الوقت نحتاج نطور عليها، وفي النهاية وصلنا أن السمبليفيكيشن، ومن السمبليفيكيشن البروفايلنج خلانا نصل إلى performance و efficiency في الفيتشر والسيستم هذه أعلى من complicated والcomplex system that we developed initially بناء على معطيات كانت خاطئة في البداية، بس ظنا مننا أنها كانت صحيحة. قبل نبدأ بالتفاصيل هذه أعرفكم عن نفسي. أنا يوسف الدليجان، أنا مهندس سينيور سوفتوير انجينير في مزن. ترجمة سينيور هذا صعب بالعربي، بس سينيور سوفتوير انجينير في مزن. صار لي 2 تقريبا أشتغل في مزن من تخرجت من كاست درجة الماجستير في علوم الحاسب، وكنت قبلها أدرس بكالوريوس في جامعة جنوب كاليفورنيا اللي هي University of Southern California في لوس أنجلوس خلال 4 سنين اللي قبلها. نفس التخصص كان كمبيوتر ساينس. هذا تعريف سريع وبسيط عني. السمري البرزنتيشن هذا مثل ما قلت لكم في البداية إن هي نتطرق إلى فيتشر محددة بالبرودكت اللي نشتغل فيه بمزن اللي هو فوكل. بس قبل نصل للفيتشر هذا اللي هي اسمها ongoing screening لازم أعطيكم تفاصيل أكثر عن إيش مزن، إيش البرودكت اللي هو فوكل، وإيش الفانكشناليتي الأساسية اللي هي function screening اللي يعتمد عليه ongoing screening. وبعد ما عرفنا التعريف هذه راح نتطرق للتفاصيل المحددة حقة المشكلة وكيف حليناها بالsimplification والprofiling and optimization. طبعا كبداية مزن هي شركة هدفها الأساسي أنها to empower organizations to make critical decisions. فإحنا توصلنا لهذه الobjective من خلال 3 أقسام مزن أو 3 منتجات. أول شيء اللي هي البرودكتس، حاليا أكبر شيء فيها الفوكل AML وأنتي فراد. وطبعا هذا منتج طلع من solutions اللي نطورها for specific customized engagement مع مزن clients. يصير أن إحنا نطور data science, AI, machine learning, technical solutions to technical problems for clients that could potentially lead to products. طبعا internally we have our Arabic R&D department or organization that focuses on building advanced Arabic natural language understanding technology, which can also be used to develop better solutions and better products for customers and users. فنتطرق من مزن البرودكت اللي هو فوكل الفكرة وراء إن it's a suite of tools that helps to solve AML compliance and fraud prevention issues. بحيث أن عندك مثلا بنوك ولا فينتكس ولا any organization that has to deal with financial regulation أن تصير عندها مشاكل معروفة عالميا، بس أن بدل ما تطور هي المنتج الخاص فيها وأن توظف مختصين في الكومبلاينس والريجوليشن عشان يطورون هذه السيستمز، معظم الوقت أنهم يشترون هذه المنتجات من شركات أخرى either through SaaS ولا self-hosted solutions، وتتوفر لهم معظم المنتجات اللي يحتاجونها عشان يحلون مشاكل الكومبلاينس ومشاكل الفرود اللي تجيهم اللي تأثر عليهم أكثر من ناحية organization أكثر من أنها compliance related. فبفوكل من ناحية ال AML compliance عندنا 4 main functionalities. أول واحدة اللي هي sanction. أنا ما انتبهت، أنا قاعد أغير سلايدز في صفحة ثانية، أنا مو نفس السلايد اللي قاعد طالع فيها، اعذروني. فعندنا في ال AML compliance 4 functionalities. أول واحدة اللي هي sanction screening، الثانية اللي هي risk scoring، الثالثة transaction screening and transaction monitoring، والرابع case management. طبعا كل واحدة لها استخدام محدد في حل مشاكل الكومبلاينس، بس الشيء الأساسي اللي بركز عليه حاليا اللي هو sanction screening. ومن ناحية الفرود prevention في ال pay confirmation، transaction fraud prevention و entity detection، وما راح نتطرق لها حاليا، بس أنها جزء من المنتج اللي هو فوكل اللي تحل لك مشاكل fraud prevention أساسا. فالحين نبدأ نعرف إيش هو sanction screening وإيش فائدته الأساسية من ناحية compliance regulation. فالفكرة الأساسية من sanction screening إن أنت كبنك ولا فينتك ولا financial institution يتطلب منك من ناحية regulation إنك تتأكد أن الناس اللي تتعامل معهم من ناحية customers ولا partners ولا third parties تعطيهم information ولا تتعامل معهم ماليا، إنك لازم تتأكد إنهم ما هم sanctioned internationally by international organizations مثل الأمم المتحدة، الولايات المتحدة، الاتحاد الأوروبي أو الحكومة البريطانية، وطبعا في لستات كثيرة عالمية موجودة. ففكرة sanction screening فوكل إن أي عميل عندك كفاينانشال انستيتيوشن تعطينا المعلومات هذه عن العميل، وإحنا كفوكل نتأكد أن هذا العميل ما هو موجود في أي واحدة من هذه الانترناشونال سانكشنز. طبعا في متطلبات مختلفة من عميل لعميل، مثلا إذا في عميل يتعامل مع ريجوليشن محددة بس تطلب إنه يتأكد من لستات محددة، ما لازم يتأكد ضد اللستات كلها، فنعطيهم الخاصية إنهم بناء على متطلباتهم يختارون اللستات اللي يقارنون ضدها. وطبعا في الأخير في سكرولينج فانكشناليتي بناء على الريزلتس الماتشز اللي تطلع من الانترناشونال سانكشن ليست هذه، تساعد العميل المستخدم إنه يحدد إذا هذا العميل الماتش حقه عالي ولا واطي. فمثلا تخيل واحدة من هذه المعلومات اللي هي الناشونال اي دي مثلا، أو رقم الجواز، أو مكان الولادة، أو الجنسية. كل هذه معلومات موجودة عندنا من الانترناشونال سانكشن ليست، تخلينا نعرف أو بدقة أكثر إذا العميل اللي قاعد تتأكد منه من خلال فوكل سانكشن سكرينينج فوكل هل هو يطابق عميل محظور عالميا من خلال السانكشن ليست هذه. فأقرب مثال يمكن معظم الناس متطرقين له في السعودية اللي هو الباي ناو باي ليتر سيرفيسز مثل تمارا وتابي، ويمكن في أكثر من في كلارنا عالميا. كلهم أنت لما تعطيهم تفاصيلك ومعلوماتك لازم هم قبل يقبلون إنهم يمولونك أو يقبلون إنهم يتعاملون معك ماليا، إنهم يتاكدون ان اسمك ما هو موجود في اي واحده من هذه السانكشن انترناشونال سانكشن ليست. فيمكن هذه عمليه تصير في الباك جراوند تشكل كاستمرز او سبيسيفيك يعني اورجانيزيشن. يمكن ما تطرق معظم الناس ما يتطرقون لها، بس كفنتك ولا فاينانشال بزنس لازم يحلون هذه المشكله تو ماتش الريجوليشنز. وفي السعوديه خاصه في ريجوليشن من البنك المركزي السعودي اللي هو سامه، اللي يتطلب منهم انهم يسوون السانكشن سكرينينج قبل يتعاملون مع الكاستمرز والشركات العالميه. فالحين اتوقع انها فكره السانكشن سكرينينج اتضحت، وفي جزء محدد في السانكشن وفي جزء محدد في السانكشن سكرينينج اللي هو ان الليستات العالميه السانكشن جلوبال ليست هذه طبعا تتحدث بين يوم ويوم. يعني مثلا في شخص حاليا ما عنده جرائم عالميه او محليه تتطلب انه يكون عليه اي سانكشن او فاينانشال سانكشن. ففي فانكشناليتي فوق السانكشن سكرينينج ان تساعد المستخدم انه يعطينا عميل ويوكلنا انه بشكل يومي نتاكد انه ما صار له اي تحديث يحول هذا الشخص من unsanctioned individual ولا organization الى sanctioned organization. فهذه العمليه طبعا تتطلب انك تسوي انك تعيد عمليه السكريننج لكل كاستمر انضاف لك في التاريخ بشكل يومي. وطبعا عدد الكاستمرز اللي تجيك بشكل يومي، عدد السكرينز اللي تجيك بشكل يومي تزيد، وعدد المونيتورد كاستمرز او الكاستمرز اللي يتطلب منك انك تتاكد منهم بشكل يومي تزيد اكثر من الريكوست اللي تجيك بشكل يومي. فلو تفكرون بالمشكله، يعني حاليا انا مثلا في اليوم انا كبنك ولا كفنتك يجيني مثلا 100 عميل باليوم، بس انا صار لي مثلا السنه الماضيه كلها او الشهور الماضيه كلها جاني مليون، مليونين، 300، 400 عميل. فالاوفر هيد حق الاون جونج سكرينينج اعلى بكثير من الاوفر هيد اوف الدايركت سكرين. فاحنا تطرق، فان شاء الله المشكله هذه بعد اتضحت اللي هي الاون جونج سكرينينج، وان احنا يعني احتاجنا نحلها بطريقه سريعه ونحاول ان توفر لنا سكيلابيلتي اللي نحتاجه و as the number of customers يعني increase. ففي دايجرام أولي بسيط نتكلم عن كيف سوينا السيستم أول مرة، وبعدين نتطرق لكيف طورناه وكيف حسناه وكيف خليناه simpler و how we profiled it later on to improve the performance. فمثل ما تشوفون أول شيء عندكم سيستم شو يعتبر معقد، يعني بعد ما أوريكم السلايد الجاي it will be very clear إنه ليش معقد. فعندكم حاليا عندكم في بداية اليوم البروفايدر حق السانكشن ليست هذه أو التحديثات للسانكشن ليست يعطينا التحديثات حق ذاك اليوم مرة أو مرتين في اليوم. تأخذ التحديثات هذه أنت كفوكل، وطبعا تحدث الانترنال metadata والانترنال information to allow يعني any future screen والongoing screening هذا to match anything that was added أو anything that was updated من السانكشن ليست هذا. يعني عندك static process تصير كل يوم تحدث المعلومات اللي تجيك، وبعدين تحدث كل السانكشنينج بروسس او sanction screening process عشان تتاكد من الاسامي القديمه والاسامي الجديده اللي انضافت او تحدثت او انمسحت. فبعد ما تجيك التحديثات وتحدث الانترنال الجوريثم والميتا داتا تجي تقول اوكي الحين I need to check the database for historical data regarding all the past screens اللي جتنا من اليوزرز. فتجيك مثلا ما قلت لك تجيك ملايين السكرينز، ولازم طبعا due to limitations في scheduling system اللي كنا نستخدمه اللي هو سالري كانت تجينا مشاكل كثيره where we had to do batching, we had over memory consumption مع result backend ومع queue broker اللي كان يستخدمه اللي يعتمد عليه سالري to distribute the work between workers. فتطرقنا ان احنا نسوي باتشنج للبروسيس، بحيث ان عندك ملايين بس every batch or every chunk your process is مثلا 100,000، وال100,000 هذا اللي تاخذها because of memory limitations and because of يعني processing limitations لازم تتابعها في الاوركستريتور اللي هو موجود فوق في النص outside of البروسيسنج نودز اللي موجوده في المربع اللي تحت. فاللي قاعد يصير يعني فاللي قاعد يصير انه قاعد تاخذ chunks of الهيستوريكال سكرينز، قاعد تقسمها على الوركرز اللي موجودين عندك through celery through يعني messages to a queue that basically get distributed into workers. طبعا initial implementation depended on the fact that we had one type of worker that did the process from A to Z اللي هو name matching, filtering وبعدين scoring. بس بعدين as we developed the system or as we tried to improve and scale the system further, we realized that the filtering process heavily depended on the database. So we thought about, okay, why don't we split up the filtering process and just keep the scoring and the matching as part of a different instance or a different worker. That's main purpose is to kind of to be CPU and memory bound to reduce that to speed up kind of the IO bound tasks and scale up the IO bound workers on their own. بحيث انه يمديك مثلا تقول ان الماتشنج والسكورينج process نعرف ان الماتشنج scoring is faster than waiting for the database to do the filtering. What we ended up doing in عندنا workers, we know they were CPU and memory bound to do the matching using our internal algorithm and the process of scoring at the end, right after filtering. And we had more IO workers compared to those CPU and memory bound workers because we can have multiple IO bound workers. We can spawn more of them and they can process multiple tasks concurrently. And that improved performance, but not to the level that we were expecting. And it added a lot more concerns and issues in terms of CPU usage and memory usage that we had to maintain and kind of figure out. طبعا this whole system had to be scaled at the same rate, and we had to do a lot of tests to figure out, okay, for how many CPU and memory bound workers do we need IO bound workers? We realized that for every 2 we need 4. So if you want to double the throughput, you have to increase the count مثلا again by 2 CPU and memory bound workers against 4 IO bound workers. And then the numbers just keep adding up significantly, and figuring out what actually has to happen gets a bit more complicated. Maybe I forgot to mention at the beginning, and the whole setup was managed through Celery. And Celery is basically a library written in Python that allows you to kind of set up workers and have them pick up tasks or messages from a message broker. In this case, it's RabbitMQ, and store results from these tasks in a result backend. And in this case, we're using Redis. Of course, that seems like a straightforward solution because it's basically what everyone does with a Python project, which is what Focal is based on and still based on. At least most of it is still some Go on the site. Yeah, so there are a lot of, I guess you could call them footguns or configurations that you have to know about initially, or otherwise you'd have to hit them as you go. And they don't work as well in this specific case, because at the start we know exactly the amount of work we need to do, and we don't know exactly how long it will take, but we know it will take a long period of time. And there are some configurations that are by default enabled for the message broker and the result backend that consumes a lot of memory, and timeouts requests if they take too long. And we know that these requests will take too long. So kind of figuring out where these edge cases happen or when they happen is kind of a trial and error process, because the number of configurations is huge and some of them are exposed, some of them are not, between kind of the message broker and Celery. So it's a lot of kind of learning how to use the tool more than actually doing the work you're required to do. So hopefully the picture of how the initial implementation that we had for the ongoing screening process of having an orchestrator that is invoked after a daily update that chunks or batches a bunch of existing monitored screens from the database into a set of tasks that are split up based on their work characteristics. Some of them are CPU bound, CPU and memory bound, and some of them are IO bound. And then you'd have to combine them and then make sure that the results are correct, and then catch errors, and then do a whole bunch of logic around it just to make sure it's functioning correctly. And yeah, so as I say, it's very complex compared to the redesign or the simplification. So if we go to the next slide, I guess you can see how much simpler it is. We no longer have a bunch of different workers. We don't have an orchestrator that has to run and keep track of which work is done. We don't have any more basically Redis to keep track of results. We don't have RabbitMQ to keep track of tasks and where they go. They don't have to consume any more memory anymore, and kind of just it's straightforward. So the main idea behind the simplification is that, okay, we know that we have to do the exact amount of work that we have to do at the beginning of the day, right after the daily update from our data provider. So the decision that we've made is that, okay, since I know what I have to do, let's just create a queue in the database that assigns specific workers the work that they have to do for that day. So let's say you have 100,000 monitored screens in the database at the beginning of the day. You say, okay, and I have 10 workers. Let's assign, let's say we have 10,000 screens and we have 10 workers. What we can say is that, okay, let's assign each one of these workers just 1,000 screens that they have to rescreen. And then they can do their own error checking. They can do their own validation. They can do their own tracking. They can ensure that all the work is done and kind of alert us that it was done. It simplified kind of the logic that had to be implemented to ensure that everything is working as expected. And we no longer have to deal with 4 different or 5 different systems at the same time, just to ensure this very simple process of screening is complete or done as expected. And of course, kind of just combining everything into a single process that does the whole matching, filtering, and scoring in one go, just made doing testing, profiling, and validating performance a lot easier than having a distributed system where you can have where do you need a distributed profiler like Jaeger, where you can send traces and spans around and kind of keep track of all of that yourself. And it gets very messy very quickly just to know what's actually going on in your system. But right now, you just have a database. You can seed it with as much data as you want, and seed it with a plan. However way you want, you can assign how many workers you have, and kind of configure all of that information yourself without having to depend on 2 or 3 other systems to set this up for you. And also, this makes local testing significantly easier compared to before. And what might be interesting here is that when we did this redesign initially, there was no performance gain. Actually, performance went down. But we were able to profile and figure out what was slow about the single process. And based on that, we were able to achieve significant improvements compared to the original implementation. So again, simplification by itself isn't the solution to I guess a complex system, but simplification allows you to do more work to improve the system as it is right now and potentially improve it going forward. So yeah, again, it's very clear comparing the previous design and the new design how significantly simpler it is, even if it didn't seem complex previously. So OGS is clear, the implementation is clear, and the simplification is clear, I hope. Now we can talk about what profiling got us, or was able to give us. So the way we did, so if you're not familiar with what profiling is basically the process of keeping track of how long each function in your program is taking, and basically telling you how much time it's spending in each part of this program in kind of a hierarchy that allows you to figure out the slow parts of your program and why they're slow, and improve them and iteratively basically make them better. There are different profiles in general, but in Python, there's a tool called PyFlame, which allows you to generate flame graphs, which I'm going to show you in a minute, that lets you visualize and easily explore kind of different parts of your profiling trace and iteratively kind of figure out what you can do to improve the performance and utilization in general. There are other tools that have been recently informed or learned about. One of them is Scalene, that kind of helps you do GPU and memory profiling on top of CPU profiling. So that might be useful if you're doing AI or machine learning work. That depends on the GPU and depends on memory consumption or reading and writing from memory significantly more than, I guess, ODS is doing that now, which is mostly IO bound. So I've taken a single process. I invoked it through PyFlame, and I was able to generate a bunch of flame graphs that allowed me to spot different parts of the code that can be improved and the results of improving that as we go. So the first optimization was offloading a kind of sublist filtering, which is the filtering step I was talking about in between matching and scoring, to bitmaps. And I can talk about this in a minute. The second part is that we use an ORM called SQL Alchemy. And because we were using a very distributed system, we were facing issues with serialization that made it very hard to or made it in some situations very difficult to serialize an object and kind of read it on the other in the other worker in a clear way. So we had to pass kind of database IDs for these objects and query them in every worker just to get a correct version of that object that we can process as we go. And getting rid of that, because now we're in a single process that does the 3 steps on their own, so there's no longer need for any of that code, improved performance significantly. And then the final part is that once everything was on a single page where you know where the matching is happening and how is it happening and where the filtering and the scoring is happening, you can see patterns that allow you to kind of reduce the amount of repetition and reduce the amount of data that you have to query multiple times in the code. So kind of just simplifying the process itself made some observations clearer that made performance better going forward. So right here is a flame graph. I guess excuse the fuzziness, but Google presentations doesn't support SVGs, so I had to convert it to PNG and all that stuff. But basically, this is a flame graph generated by using PyFlame. You can also generate it using different traces. I think there's a tool called Prof in Linux that allows you to trace just any program you want. And then there's a script called flamegraph.pl, which is, I think, a Perl script that generates these flame graphs for you. And they're pretty useful. It kind of the graph doesn't tell you anything about time. It just tells you what percentage of the program is taking how much of your code. So in this case, you can see that the central part, hopefully it's clear. I can get a pointer. It was hard to get a pointer. So hopefully the central part, which has basically the widest rectangles, is very clearly taking around maybe 75% of the program's time. And it was very clear that once we got the profile is that this part of the process, which is the filtering that I was talking about before, was taking most of the time. And it was taking a lot of time because we were doing basically a lookup on IDs in the database, but there were multiple layers, and we're doing JSON joins and a whole bunch of messy operations just to get this to work. So we decided to go with a different, simpler approach where we just ended up using bitmaps. So every time you as a user would specify a specific sublist that you want to match against when doing a screen, the default option is to kind of screen against everything, so that's fine. But in a lot of cases, customers or users are screening against specific lists. So when you want to screen against a specific list, you basically you used to have to do kind of a complicated join on JSON tables that required to get IDs of these lists and comparing them against what was requested. And then you had to depend on the database to do the optimizations. It was all over the place. But using bitmaps, which if it's not clear for everyone, a bitmap is basically a more optimized set. You can give it an ID and ask it. You can initialize a bitmap by giving it an ID or a key and tell it in the future, does this key exist? And it's more efficient in terms that it just stores bits instead of actual objects themselves, and it's less complex than a set. You can't iterate over it. You can't get the actual original value from it. It just checks. If something is there, then it tells you true or false. And the bitmap was basically able to given any match, check if this match exists in a sublist. So for every sublist, you have a bitmap that includes all the entities or all the matches that could potentially come from any screen. And then if that match exists, then just tell me it exists. It exists based on what the user was asking. If it doesn't exist, then just throw away that result. But if it does exist, then just keep it and continue to the scoring step. And of course, hopefully that's clear. If it's not clear, we can discuss this right afterwards. But the gist of it is that we had a lot of database queries. We moved them to CPU bound bitmap checks. Preferably, we could have used bitmaps in the database. Postgres supports bitmaps as a database column type, but MySQL doesn't, so we had to do it on CPU and in memory. It was good enough for us, so it was fine. But yeah, in the best case, we would have just made the database query that gave us this result right away. And then this is the second flame graph generated after we moved to bitmaps. Maybe it's not as clear, but now we have a different segment of code. Even though it's in the middle, it represents a different part of the code that had to do with kind of inserting results into the database after they were found. So we have a different bottleneck that we have to fix right now. And the fix for this was basically just, as I said before, getting rid of unnecessary database queries that were already done at the start, but were necessary because we were using different workers and passing data between them. And and then after these optimizations, we were able to get this final kind of trace that kind of shows an equal distribution between the different parts of the task, where you have the compare screen result, which is kind of the final storing result of the process. Sorry, I keep forgetting to switch the slide. So you can see here, this is the final trace or flame graph that shows the final trace for the current state of the application. But you can see different parts of the program are taking around the same amount of time. And we reached the point where we're able to achieve performance that was good enough given the amount of work we spent on it. And we have future optimizations. For example, if you see on the far right, this is the matching step. And there's a parsing step that happens at the start that makes it, that could be optimized by caching some results initially before doing the OGS process. But we haven't gotten to it because it wasn't necessary, because we're able to achieve better performance than we had before, and can talk about the improvement in performance right afterwards in a bit. But yeah, so we went from something that was basically this big, where we had a specific bottleneck that was very clear, very obvious. They were able to identify, improve a different bottleneck, and that resulted in basically a trace that was reasonable, and there was no very obvious point of optimization that would give us a significant improvement compared to the 85% and 75% kind of time utilization that the other two functions would take. One final realization that we had as part of kind of the simplification and optimization is that once we deployed this implementation into production, we started noticing that some workers were not picking as much work as they should be. So, for example, you have 2 workers. Each worker is assigned 5,000 out of the 10,000 screens that you have. One worker would finish within an hour, but the other worker would take 2 hours, 3 hours. And it wasn't clear why. The conclusion that we got to is that some workers don't perform as well because of either neighbor interference or some other basically issues within the system or the instance that we couldn't control. So what we ended up doing is that we quickly and easily changed the database tables that keep track of which worker is doing the work by just setting up the work that has to be done. And then each worker would be able to pick up a specific task and finish it. And if a worker is done with their task, they can check if there's another task that they can take, and then they can keep processing them until they're done. So it's like it goes back to the queue implementation in a database that allows you to kind of support only what you need and kind of get rid of all the extra stuff that you have to configure and manage, even though you might not necessarily depend. And as part of this, we also implemented snapshotting, where if a worker dies in the middle of, for whatever reason, because of an error or some other issue, they kind of keep track of where they last stopped in the database, and they can just pick up and continue where they left off without having to redo all the work that they were doing. And the general idea here is called work stealing, and it's available on kind of other types of work stealing scheduling, and it's kind of available in different parts of computer science, software engineering, and it made sense in this case. In terms of results, which I was alluding to before, we were able to get a 2 times performance improvement, but with 3 times less resource utilization. So previously, we would have, for example, an instance with 64 gigabytes of memory, 6 CPUs, and it was only able to do kind of half of the amount of work that 20 gigabytes and 1 CPU was able to do kind of on its own compared to this much. So if you imagine you have I'm just going back a bit. So if you imagine the square in the middle represents a machine with 64 gigabytes of RAM and 6 virtual CPUs, so you can have around 12 actual, or 12 virtual CPUs or 6 actual CPUs. You'd basically require that much to get around half of the performance that you're getting from just a single kind of worker on 1/3 of the resources. So on the same instance, you'd have kind of 3 replicas of this new simplified OGS worker compared to 6 containers just doing the work that basically one or half of a simple new implementation of OGS can do. So hopefully that's also clear. And the developer benefits are obvious. Like the first one is that being able to profile without having to deal with kind of distributed tracing and dealing with all the issues that Celery has and all the issues that managing a process can take long term. And testing is easier, kind of iterating over the implementation is easier. There's no dependence between different parts of the code on kind of the workers that we're using, and there is no dependence on kind of other services that already exist. That makes it very hard to just iterate on the implementation, that's all. And the other benefit that we got from this is that we had a very clear scaling unit. So we know the throughput of a specific kind of instance of an OGS worker that, given 20 gigabytes of memory and 1 CPU, we'd be able to give X amount of throughput an hour. Now we can say, okay, we have this many screens in our database. We can automatically kind of scale up the amount of OGS workers we have depending on the load that we have, compared to previously where we had IO workers, CPU and memory bound workers. and you had Redis and RabbitMQ, and you have to scale those at different levels and different amounts just to be able to kind of achieve the same throughput with a simpler, more compact system. So going forward, what this taught us at Muzin is that kind of simplifying things is the better approach to implementing systems, even if you have existing technologies or existing libraries that kind of solve the problem for you. Maybe going back and trying to not implement the whole thing yourself, but trying to solve the problem with as little amount of kind of extra functionalities or extra features is the way to go. So we've been kind of exporting this to other parts of Focal, like sanction screening itself. We're trying to simplify the design, simplify the implementation, simplify the dependencies, and try to basically get a unit that we can test, profile, scale up, and kind of identify the weak points of it, and potentially apply it to other parts of Focal itself. And as I said, there are more profile and optimizations that we can do to the ongoing screening process itself that can give us even more throughput, given the same amount of resources that we could do going forward once we need it or once we kind of have limitations in terms of cost or throughput. Just to summarize, basically, I gave you a quick introduction about Muzin, Focal, and sanction screening, and defined what ongoing screening is, and then went through the process of kind of what the original implementation of ongoing screening is, what the new implementation is, and what it allowed us to do in terms of profiling and improvements, and what the result of that was, and kind of how it helped us internally in kind of figuring out exactly what was wrong about our assumptions. Even if it made sense back then, it would have made more sense given the knowledge that we have right now to implement it in a different way. So I hope, so we've got to the end. And I'm leaving a whole bunch of time for questions and to discuss kind of different parts or different details if anyone has about maybe the implementation or the tools that were used.
طيب جميل والله يعطيك العافية مهندس يوسف، شكرا على هذا المشاركة الجميلة. أنا شايف يعني في مجموعة من الأسئلة بدأت تنطرح الآن، لكن أنا أكرر يعني أدعو الجميع اللي حابب يعني عنده أي سؤال المهندس يوسف ممكن يطرحه على سلايد الآن. فضلا تطرحوه على سلايده، وفي نفس الوقت تعملوا فوت أب لأي أسئلة تشوفوا إنها مناسبة. في عندنا سؤال من سيف الحارثي، وانتبه عاد أسئلة سيف تكون معنا. تمام، فهذا سؤال من سيف. هذا أتوقع كان سؤال هو قبل يعني انطرح قبل فترة شوية. عندك تعليق عليه أو نأخذ السؤال اللي بعده؟
سؤال لا بالعكس، عندي تعليق. الأورمز لها يعني فائدتها انك تبدا بسرعه وانك تحل، يعني ما تفكر بمشكله الداتابيس، بس تعطيك مشاكل هي لما توصل لمرحله انك you have to make custom queries, you have to make queries that the ORM wasn't designed for. يعني مثلا اتوقع SQL Alchemy is mostly tested مع Postgres، فيمكن تجيك مشاكل لما تجي اوكي في حالتك انك قاعد تستخدم MySQL في some functionality that isn't supported ولا new functionalities that you want to use or you want to utilize، بس you have to write your own SQL query. فالSQL Alchemy ما له فائده. بس الأورم بعد تساعدك من ناحية إن إذا عندك تيم مثلاً وقاعد تطورون different features different functionalities، تساعدك من ناحية يعني اللي هو managing migration، وتساعدك من ناحية managing objects managing state، بحيث إنه ما تحتاج إنك كdeveloper إنك تطور connection pooling for example، ما تحتاج تطور اللي هو state management. إنه مثلاً SQL Alchemy يعطيك functionality هذه which is fine for most cases، بس if you're performance oriented اللي هي يمكن تسبب لك مشاكل، بس اللي هي انك مثلا lazy loads objects، فمثلا او تعطيك relationships، فمثلا عندك table A و table B، table A عنده one to one relationship to table B، بدل ما انت بنفسك تكتب الجوينز وتكتب الqueries اللي تعطيك الجوينز هذه كلها. In most cases or most web apps it might not be an issue, so you can easily use it to directly reference this and SQL Alchemy to automatically load it in a database query. بس مثلا if you have code that's مثلا in this case performance oriented, you might have to end up either working around these limitations, doing the eager loading yourself بحيث انه you load all the information من البداية بنفسك حتى لو it's not useful for most of the app but you want to share the code with other parts. وطبعا يعني لها فوائد ولها مضار. المضار دائما تجي في البرفورمانس ايشوز. المضار في يعني في مضار ثانيه you can work around them بس you have to be conscious about them. والفوائد طبعا كثيره من ناحيه الديفلوبمنت سبيد والاتريشن وهذه الاشياء بس again you have to be conscious about the limitations. يعني لما you develop a feature تعرف ان هذا limitation بيجيك ف you have to know about a potential solution for it لما تجيك المشكله او انك ما تتطرق لها في البدايه وانك تركز على البرفورمانس وتترك مثلا الفانكشناليتي والديفلوبمنت مور فيتشرز جوين فورورد. بس تريد اوف كل شيء تريد اوف صار.
جميل. طيب هذا برضو سؤال من سيف بس عشان نخلص من اسئله سيف
انت ما تخلص
تمام. فما اعرف اذا عندك تعليق على السؤال هذا.
هو potentially we could بس الكور algorithm السانكشن string ولا name matching algorithm that we have internally is written in Python was developed in Python. So it was easier to integrate everything in Python rather than rewrite everything in Rust. يعني we could rewrite the algorithm itself in Rust, but again, iteration من ناحية data science من ناحية any future changes might be harder to implement if you do everything in Rust. خاصة إن Rust developers أساسا I'm feeling كثير. يعني it's in terms of being able to kind of develop R&D من ناحية ال AI machine learning و data science والdeployments الأسرع من ناحية اللي هو الcoders والdevelopers.
جميل. طيب هذا سؤال من طلال إذا تحب تقرأ أو تجاوب عليه مباشرة.
All the heads can be repeated after everything ends per worker or used to So screens don't fail unless there is a issue with the screening itself. So failed screens are monitored or not monitored, kind of we're alerted about failed screens and we can deal with them as they are because a failed screen means that screen itself didn't there was an issue with the screen, so retrying it multiple times wouldn't make sense unless it's some internal error. And if that's the case, then you can just redo the screen. You can invoke a mechanism to kind of redo the screen itself, and it wouldn't be an issue.
جميل. طيب
I hope that answers the question.
أيوة عندنا سؤال من مهند. لحظات هذا السؤال.
So it's again knowing about complexity requires experience. يعني initially the idea يعني the complex idea we thought was the better implementation. يعني the more experience we got or the more experience we got within people within the more experienced people we got within the team were able to kind of identify different parts of Focal that kind of are too complex or can be simplified in terms of logic and functionality. And by exploring those, we were able to verify that that was the case. But if once we explore them, once we say, okay, this is complicated, let's try to simplify it and see if it can be improved. And if it is improved, then we know for a fact it was complex and too much. So there is no clear way of answer of saying, okay, this is too complex, simplify it. It's a way of saying, okay, I've seen systems like this. This seems complex. So let's try simplifying and see what that does.
طيب جميل. يعطيك العافية. أنا أتوقع يعني هذه الأسئلة اللي وصلت حتى الآن. ففي نهاية هذه الجلسة أحييك والله مهندس يوسف. يعني يعطيك العافية على المشاركة المميزة جدا هذه بشركة موزون كشريك نايف معنا. آسفين جدا إن كان سهرناك معنا يعني الآن.
لا والله
الله يعطيك العافية. فجدا نشكرك يعني عن هذه المشاركة وإن شاء الله أنها تكون يعني بداية تعاون مستمر معاكم بإذن الله في مشاركات مستقبلية قادمة. يعطيكم العافية وشكرا جزيلا، وإن شاء الله نشوفك على خير معنا دائما المهندس يوسف. مرة مقدر وقتك وجهدك معنا وإضافتك القيمة المعرفية معنا في هذه الجلسة. يعطيك العافية، شكرا جزيلا. شكرا
على الاستضافة وشكرا على كل شيء، وما شاء الله يعني الإيفنت كان ممتاز.
الله يعافيك ويسلمك، فرصة طيبة، في أمان الله.